Hi guys, welcome back to another weekly webinar. So we've had some fun in the last 3 weeks. We've discussed some really difficult questions of various topics of basically critical reasoning and time, speed, distance. Today we are going to take a topic which is itself a little difficult. So we are going to stick to easier questions on that. Let's say to 700 level. We look at probability and the very basics of probability. Yeah, so we'll talk about why probability is favorable outcomes upon total outcomes and how to use that. So we will take some harder questions as well a little later in some other webinars, upcoming webinars. Yeah. Okay, let's try this now. So three friends, A, B, and C, will participate in a race. If there are total 8 competitors in the race and top 3 positions will be given a gift watch. What is the probability that at least 2 friends will get a gift watch? Now, is this a permutation question or a combinations question? Think about it. Yeah, agreed. There is a race, right? So then there will be someone who'll come first, someone second, someone third. But then does our question deal with those rankings, with those positions? No. So we're talking about 8 people, and we're saying that there'll be 3 of them, the top 3, will be given a certain gift. So this entire group of 3 is identical for us. They're all the same for us, right? We are not ranking them in 1, 2, and 3 positions. So actually, it's nothing but a combinations question. Right? Okay, now we need the probability that at least 2 friends will get a gift watch. So there are 3 total number of ways. What is total over here? Total is how many people there out of the 8 competitors, we will select how many people? We'll select 3 people, right? We need the probability that out of those 3, at least 2 friends get a watch. All right, so what is the total? Out of 8 people, we have to select 3. Mhm. What are our favorable cases? Our favorable cases are that at least 2 friends get a gift watch, which means either all 3 of them get a gift watch or 2 of them get a gift watch. Now, all 3 will get a gift watch in how many ways? If out of 8 people, I have to select only those 3 friends, in how many ways can I do that? I can do it in exactly one way, isn't it? I just select those 3. There's only one way of doing it. It's a selection, and there is no arrangement that we'll do for them. Okay. Then favorable cases. One is that case where all 3 get a gift watch. Plus, there are some other favorable cases as well, in which 2 of them get a gift watch, right? So, how are we selecting the 3 people? Out of our 3 friends, we are selecting only 2. We've already taken the case where we're selecting all 3. And out of the remaining 5 people, we are selecting 1. So we could select the top 3 in these cases, in these number of cases. This gives us what? 1 here. It's an addition, right? Right. So, okay, here I'll do the calculation. Why? Because it is an addition. So anyway, I can't cancel off stuff over here. So now I'll say 1 plus 3C2 is the same as 3C1. So 3 into 5C1 is same as 5. So into 5, this gives me 60. And 8C3, how do I calculate that? Simply start by writing 8, go down into 7 into 6 till 3 because I have R equal to 3 divided by 3 into 2, which is what? 6. So I cancel this off, right? So I get 8 into 7, which is equal to 56, right? All right. And then my probability that is going to be favorable upon total, which is going to be 16 upon 56, which is equal to 2 by 7 divided by 8. So you get the answer as P over here. Keep in mind that in this question, we don't need to, okay, just let me see. Yeah. Yeah, yeah. What happens if you arrange? Nothing happens. You will still get the same answer, but you'll have to do a whole long calculation at that, right? Let's say if I try to arrange these people, my total cases are I have to arrange all of them in how many ways I can arrange them in? 8 factorial ways. If I want my all three friends to get the watch, then I'll have to the three friends arrange them in 3 factorial ways in the first three positions and arrange the others in 5 factorial ways in the other 5 positions. If I want two to be there in the first selections, in the first cases, first I'll have to select two people out of the three. I'll have to select one person out of the other five, which is my 5C1. Then I'll have to arrange these top three people and I'll have to arrange the 5 factorial, the 5 people, right? Finally, my answer will still be 2 by 7 only. It doesn't really matter at all, but I would end up doing so much of calculation, right? So it is important for me to realize, for us to see that here the ranking doesn't matter. I don't really need the first, second, and third spots because everyone is getting the same thing. Why have I been given that will be given a gift watch? It means that each person is given the same thing, which means that each ranking is the same. So that is why we don't need to arrange over here. Okay. The yellow box contains 4 white balls and 3 black balls. Okay, so there is a yellow box and it has 4 white balls and 3 black balls. The blue box contains, so there is a blue box as well. It contains 6 white balls and 2 black balls. Both are black, right? Now, one of the two boxes will be chosen at random. So there are two boxes. One of these will be chosen at random. That means the probability of choosing either box is half. Boxes are, it doesn't matter. There is no reason why you would choose one with a higher probability, right? Either I would choose the yellow box or the blue box, right? There are two ways, and I would choose the yellow box in half the cases and blue box in half the cases. They're saying the box is chosen at random. Okay. And then two balls will be drawn from that box at random without replacement. Again, then two box, at random, 2 balls at random means we'll just use combinations, right? We'll just say, okay, so 4C2, 7C2, whatever, right? So we're just picking them both together. Okay, so what is the probability that the two balls drawn will be of the same color? So we need, so okay, what is the first step? First of all, we have to select a box. So we can select, let's say, the yellow box with the probability of half. All right. Now, what is the probability that the two balls, now let's say our yellow box is already selected. Now I need the probability in the yellow box that the two balls drawn will be of the same color. So that's my favorable cases upon the total number of cases, right? So I have 7 balls. So this is going to be what? 7C2. That is the total number of cases. Now, in how many cases will I have two balls of the same color? 4C2 in case I'm picking 2 white balls, plus these are additional cases, right? Either I can pick 2 white balls or I can pick 2 black balls. So or is given by a plus, right? Plus 3C2. So these are my favorable cases. These are the cases, these are the number of ways in which I can select two balls of the same color. And these are, of course, the total number of ways. Make sense? Okay. Now, say I picked up the blue box. The probability of that was half because I could have picked either, right? Now, if I have to pick two balls of the same color out of the blue box, in how many ways can I do that? Again, 6C2, I can pick up 2 white balls plus 2C2 because I can pick out 2 black balls as well. Again, I'm going to add these divided by the total is 8C2, right? So now this is the entire thing. This is going to give me the, when I add them up, it will give me the probability that the two balls drawn will be of the same color. Because again, this probability is added to this probability because either this will happen or this will happen. Okay. So, okay, now in case we have to solve it, how are we going to do it? Simple enough. I say half into 4C2. Think about it now. You don't even need to, write down 4 into 3 upon 2. Think about it orally. So you have 4 and you have 2 at the bottom. So it gets cancelled. You're left with 2 into 3, right? You would have otherwise written 4 into 3. So then you left with 2 into 3, which is nothing but 6 plus 3C2 is simply 3. So you have 3C2 is 3C1 and 3C1 is simply 3, right? So divided by 7C2. 7C2 is 7 into 6 divided by 2. Let's do it right over here. So we divide, this becomes 3. I get 21. So 9 upon 21. So I get 9 upon 42 over here. This is this particular calculation. Okay, plus let's say half into 6C2. Again, think of it. 6 into 5 by 2. Just imagine in your mind. 6 into 5 by 2. 6 gets cancelled with 2. You left with 3 into 5 by 2. You get a 15. Plus 2C2 is simply 1 divided by 8C2. So 8 into 7 upon 2. So I get this cancels, this becomes 28. I get 16 upon 28. I'm not going to go with 16 upon 28 because I can divide this by 4 further. So 4 by 7 and 7 into 2, 14. So plus I have a 4 here upon 14 here. All right, now, excuse me. 14 into 3 is 42. It's a good idea to know the multiplication tables. So then this thing is nothing but 12 upon 42. This is nothing but 9 upon 42. When we add them, what do we get? We get this is equal to 21 upon 42, which is nothing but half. So the answer is half. Now, none of the options has half, right? So test takers sometimes get really confused that there is no half there. What do we do? Well, it's just a sneaky way of giving the option. Look at this. You have a 4 by 8 here. So which is equal to half? So then your answer is D. Yeah, just look at each option carefully once. Yeah, don't jump back that I must have made a mistake. Just look at the options a little carefully. Sometimes test takers just being a little sneaky. Yeah. So the answer here is half. Okay. Let me know if you have any questions.